Questions on the test, you just have to read me a problem. Everybody else can find the problem on their test if they want to follow along.
A shirt company has 4 designs of which can be made with short or long sleeves. There are 7 color patterns available.
What number is it?
How many different shirts are available from this company?
So this shirt company's got 4 different shirts,
Short or long?
short or long sleeve, and there's 7 different patterns.
I just didn't do
What are we gonna do with those
multiply
numbers?
them.
What number is this? I did not get that right.
What are we gonna do with them?
You just multiply it.
Multiply them, I think it comes out to be
Isaac, what number is
56.
it?
Mr. Ebersole.
What number?
I know it doesn't make a difference, but you marked one wrong, and this was right on his.
Because I like Isaac better than I like you.
What number is
This is the
this?
same question.
What number was this question?
9.
What about the shirts?
Oh, I got it right.
Answer's 56.
That was a guess,
And then
though.
can you
Yeah, I
number
got
8
that one
right
right.
above it?
Read it to me.
How many license plates can be made consisting of 2 letters followed by 3 digits?
This was also a guess.
2 letters, 3 digits.
You got-
How many choices do you have for a letter?
26 options because it doesn't specify.
Digits?
10.
10.
Please multiply
Mine
Okay,
multiply
I
those.
did it right, I just didn't
it.
add another
676,000.
Another 0, why wouldn't you?
0. I put B, I needed another 0 to make it.
I got that
Oh.
wrong then. Okay.
Think it comes out to be that?
Again, right here's wrong.
Well, it probably just-
Find the probability of answering 2 multiple choice questions
Oh, it's
correctly.
not, never mind, right.
If random guesses are made, assume the question each have 5 choices for 1 answer.
All right.
What are we on, Jen? 12.
So the first answer.
Only
What's,
one of them is correct.
you're guessing on the first question. What's your chances of getting it correct? What's the
1
probability?
out of 5.
Second question.
1 out of 5.
What do you do with those 2 to find the overall probability?
Yeah.
Oh, what do you get?
2,
I don't know what that is decimal. You can figure it out. You can
0.04.
calculate.
So what would we do if we would add them? I don't know why I added them. I thought I was supposed to.
If,
I added them.
let's see, if it would have said,
I put 2 out of 10.
let's see, how could it have been worded to you make it addition there?
I was so close.
Well, I think I did both, but I just, because I wrote down both ways, but I
What's
just.
the probability of you get the first one right and the second one right? If you added it.
No, that'd still be multiplying. If it said the probability, if it said something like, there's one question and answer A is correct, we're not doing a second question, and then Ebersole figures out, like you did on one problem, that answer C is also correct. Now what's the probability of getting this question right? And then it'd be, if you answered A, it'd be 1 out of 5, plus if you answered C, it'd be 1 out of 5. So then the probability would be 2 out of 5.
The probability it will rain 40% each day over a 3-day period. What is
Which
the
one's that?
probability it will not rain at least 1 in 3
It's
days?
number 29.
So the probability, or the rain, listen closely on this. They want the probability that it will not rain. And this is probably, I don't know if I'd say the hardest one on the test, but close. Probability it will not rain
What number is this?
at least 1 day. So you got something going on. You got a graduation party, and you got a 3-day span here that you could have it in. And you watch the news, and they say there's a 40% chance that it's going to rain all 3 days. And you're crossing your fingers, hoping that one of those days it doesn't rain, so you can have your graduation party on that day. When I'm looking at a problem like this, what I do is I think, okay, you know, what's the probability that it rains one of the days? What's the probability that it rains 2 days? What's the probability that it rains all 3 days? What's the probability that it doesn't rain any of the days? And I'm thinking about this, and then I look at this. This says the probability it will not rain at least one of the days. So not rain at least one of the days. The only one of these probabilities that doesn't fit into this right here is if it rains all 3 days. If it rains one day, then I'm okay. I can have my party on one of the other 2 days, right? If it rains 2 days, I can have my party on the day it didn't rain. If it doesn't rain any of the days, then I can have it on any of the 3. So all of these would work. So we could take the probability it rains 1 day plus the probability it rains 2 days plus the probability it rains 0 days, add all those up and get the answer. But an easier way is to use the complement, and the complement would be the probability that we can find this probability it rains 3 days, and we just subtract that from 1. If we find the probability it rains all 3 days, all we're going to do is use the probability first day, second day, third day. What's the probability it rains on the first day?
40%.
So 0.40. What's the probability it rains on the second day? 0.40. What's the probability it rains on the third day? What are we going to do with all those? And again, when you're looking at this, if you think addition, on your calculator real quick, what's 0.4 plus 0.4 plus 0.4? Can a probability be 1.2? That doesn't work. So something's not right there. So we're probably not adding there. We're probably multiplying. Didn't it come out something like that? You subtract that.
I didn't get anything.
So what's the chances that one of those 3 days it's not going to rain?
93%.
About 93, 94%. So even though you see this, you're looking at today, tomorrow, and Sunday, and you see, and it says 40% chance of rain. And everybody always thinks, oh my God, no chance then, because it's going to rain every day. It's 40% chance. No, if it says it's 40% chance, then that means there's a 60% chance that it's what? Not going to rain. But that would be your answer on that. Other questions?
30.
30?
24 after
Read it to me.
How many different permutations of the letters in the word probability are there? Distinguishable.
that. Oh, I got that one wrong too. Perfect.
Probability. I hope I spelled that right. And they want distinguishable this time, right? Remember the formula for distinguishable was n factorial over n1 factorial times n2 factorial times so on all the way out. These are just the ones that repeat each other. How many letters, total letters do we have?
11.
So on top we got 11 factorial. Is there more than one P?
No.
R?
No.
O?
No.
B?
Yeah.
2.
So we do 2 factorial on bottom. A?
No.
B we already did. I?
2
Yes.
eyes.
So 2 factorial.
There's nothing else.
Nothing else? 2 factorial on bottom, that's 4. 11 factorial, you can figure that out on your calculator. Divide it by 4. What's it come out to be?
Is it 9979200?
Is that right?
Yeah.
Did we already divide by 4 or not?
Yeah.
Yes.
That's already divided by 4, so that's your answer.
I was in close. I can say, yeah, 24, it says, a delivery route must include stops at 4 cities. If the route is randomly selected, find the probability that the cities will be arranged in alphabetical order. Round your answer to 3 decimal places.
So permutations or combinations, if we got 4 different cities, let's just make these cities A, B, C, and D. Are we using permutations or combinations? Permutations,
Matters
because
it wants to read alphabetical.
because A, B, C, D is different than B, A, C, D, right? If we use combinations and we did this, 4 cities, taken 4 at a time, our answer would come out to be, there's one way to do it. So that didn't help us any. So we want permutations. 4 cities taken 4 at a time. Somebody help me out with that.
And 24.
24? So 24 different ways that we could arrange those 4, or deliver to those 4 cities. How many different ways are going to be in alphabetical order?
One.
One.
Whatever 1 out of 24 or 1 divided by 24 is.
0.0416.
Was this a multiple choice one or was it?
Yeah.
I apologize, I know at least one of the problems, it said round to 3 decimal places and then all the answers gave like 6 decimal places, I don't know.
See, this is why, look, there's so many that I had to answer, but I erased it because I second guessed. Because I put C and then
I just wanna, I have a question.
I put D.
Why is the
I would have at least gotten probably 5 or 6 more right.
Because I got it right, you didn't take points off, but you circled it, and I got it out.
No, it's because you didn't need all this other stuff. So list the sample space.
Did you do 18?
I still got it right.
18.
I might mark it wrong next time if you're gonna argue with you.
Not mutually.
Because I over-explained.
Yes,
Okay.
because when it says list the sample space, I don't want all that other crap, I just want
Didn't get it right.
the sample space.
It said short answer.
I think 20 is B. There's 20 B. It's short.
What one is it? What number?
Oh, whoops.
That's a short answer.
That's what you put?
What'd you put?
Didn't say short answer plus extra.
Well, what would it
I'm
be?
sorry.
'Cause
I don't know, I
either
thought you added them.
Or you did. What's 20? Or you
20,
did-
yeah.
And then my other
Oh,
answer
read it.
wasn't short
The
enough.
events A and B
Or
are
what's
mutually
it?
exclusive. If probability of A equals 0.3 and B, or probability of B equals 0.4, what is the probability of A and B?
I love
Which
this
number is
question.
this?
When you- and
20.
I love
Is
this
it
question.
0 then?
These 2 events are mutually exclusive.
Yeah.
It can't happen at the same time, so it'd be 0.
So what's the probability that A and B both happen at the same
Oh.
time?
What the heck?
I still don't understand the card questions. I literally wrote down all the things like you told us in class, and then I used
Did
them.
any of us get that one
And I
right?
still didn't understand.
0.7.
What, the one
I
on
put
zero?
.7 too.
I also put point
Yeah,
seven.
did you get it right?
I
Lily did.
thought that was an easy one.
Okay, what
If-
about?
If it would have said this,
Did you get 19?
No,
I did.
You
the
got
card
Then you'd
one
add.
confuses
Probably-
me.
I did.
give me, you want,
Did you get 19?
The card ones? Okay, 19.
19.
A card is drawn from a standard deck of 52 playing cards. Find the probability that the card is an ace or a black card.
I swear you I did this right.
Like, I
What did you
literally was
put?
I got
looking,
19.
I was looking
That's
at
what
my
it is.
notes over and over again, and I still couldn't make it make
7/13.
sense. Any answer that I
It's
got
7
was
over
not
13.
an answer. I don't know how.
so we do this, what's the probability you get an ace? So how many times are we drawing, first of all?
2.
One time.
No. one-
Because we're drawing, it says ace or black, so we're drawing once and we want one of those
So
things.
you have a
What's the probability of getting an ace?
4
Four
out
out
of
of
52.
52.
Then add
What's the probability of it being black?
26.
6.
But then don't you add the top two, so it'd be 32 out of 52?
That'd be 30.
But,
Or
listen,
30 out of 52?
but
Two of the
listen,
aces are-
but what, Michael?
but 2 of the aces are black.
So this one's not mutually
Oh.
exclusive. Remember, we had a different formula. When they're not mutually exclusive,
subtract 2.
you gotta subtract off the 2 that you counted twice here.
You know how to play like cards.
Well, I started it right, I just didn't do that part.
Oh, look.
And you end up with stuff like, something like that, and then you could reduce that down. Again, on your calculators, everybody know how to reduce on their calculators?
I forget.
No, I just
So
said
push-
that's the lowest thing.
Push it in, type this in right now, and I'll tell you. You get 28 divided by 52, and then hit the math button, and the very first thing says fraction, hit enter, and it'll reduce it for you. What's it
Yep.
say?
7 out of 13.
And then the other kind of question I got wrong too.
Did we redo this?
Honestly, I gotta see on that.
Are we done?
No, no. Hang on. Richie?
Which is average.
Well, I need this class figure.
You don't have another map?
No, because you
Can you do 33 and it says,
I got one bonus right.
how many ways can a jury of 8 men and 8
Yes.
women be selected from 12
That
men
was-
and 10 women?
that one I actually think I did.
I have no clue how to do that. 33.
Oh,
See,
wait.
those ones killed me.
I
'cause
thought
they're
I
like
did it right,
-3,
but I
-3,
Oh wait, no,
minus
I did most of it right. I just
Now,
added instead of.
I apologize for this one as far as, because I think I was out the second day when we did some of this stuff and then I was out. And so we didn't really get to go over this real well, or as well as I'd like to. All you do with this, we're taking 8 men out of 12, so we're picking 8 out of 12 of the men, 8 out of 10 of the women, and we're putting them on this jury.
But it doesn't matter what order they're
So
in.
is that permutations or combinations?
Combinations.
So for the men, what goes in front here?
The bigger numbers.
What goes here?
8.
So let's find that.
Oh,
It's 495.
Oh.
For the women,
That's not what I did.
It's 10.
10.
And then 8.
Now, I'm not sure why we're picking 8 men and 8 women. I guess there's alternates maybe, because that's 16 and usually a jury only has 12.
I knew.
But that's good that you guys don't know that, so,
45.
not yet at least. Isaac will need to know it in the future.
Very good chance.
And then I added them, but he says that you have to multiply.
And you multiply those two together.
How many points were these questions? Did you?
3.
3.
Some of them were 3, some of them were 2, some of
So
them were
because
1.
I showed my work, I got.
Maybe.
Okay. Because then.
Yeah, that's the page that hurts me.
I think I might have said that right before the test.
So then
too.
wait,
Hey,
what
show
do
us
you
all
do?
the
This
work.
back page hurt me.
You multiply those two together?
Yeah.
Yes.
Yeah, this screwed.
What did it come out to be?
What does that say list?
I have to multiply.
Oh, this rolling 1, rolling 2, rolling 3, rolling 4.
22,275.
I said, whatever the number.
You got 22,000?
495 times 45.
Is that not right?
That's a lot.
495
That's why I thought my
divided
540
times.
was.
Oh, I did
45.
40.
You're
You're
right.
right.
Other questions?
Hang on.
I pretty much know everything else.
That
No,
was
but
over
I just-
with.
Now that I look at it, I
Yeah, now that I look at it, I
dumb
feel
mistake.
dumb. I just went slow.
I'm sitting there looking at it.
35 says in the California state lottery, you must select 6 numbers from 52 numbers to win the big prize. The numbers do not have to be in a particular order. What is the probability that you will win the big prize if you buy a ticket?
So if they're not in a particular order, what are we doing?
Combination.
Yeah.
And we're taking from, what did it say, 50,
52 numbers.
and we're taking how many?
I'm-
6, I think.
Yeah, 6.
Somebody figure that out for us.
Yeah, see, now that I just.
See, I did that, but the only reason I got points on it is I didn't put
200 or 20,385,500.
Got that. I didn't put a 1 on top.
Can't beat it.
So that's how many different ways the lottery could come out. To find the probability if we buy one ticket,
Put 1 over.
I put the 1 over the top, I just got the answer.
so it's 1 out of that. You could change it to a decimal if you wanted. Somebody do this for me, because I'm a little confused about this.
6,
What?
0,
How did you
0,
do it?
If, because I think that
10,
mathematically, we
26,
should be able to say,
10, 10.
how many different choices are there for the first number?
Multiply it all together.
There's 52.
How many for the second number?
52.
No.
51.
How many for the third number?
50.
50.
4?
I started
50.
that.
49.
Sorry. Fifth?
48. 47.
Now, if you multiply that together, for some reason it doesn't come out the same as that number.
That's what I did the first time, it didn't make sense.
And I think it, you know, it seems like it should, but
I think it's because,
I think it's because this number, we're saying, once you pick that number couldn't be picked anywhere else. And so that's why they end up being that, a little different.
Because if you do that,
This
you
is
get
the
like a
correct-
trillion. You get like a trillion.
Right.
1 trillion.
I'm not sure. I don't know, I'm gonna have to look into that more, of why that doesn't.
I just feel goofy now. Cause I don't know how to do everything, every single one of
You
mine.
missed it.
Braden's not here to ask me, because I think one of the only questions that he missed on there was the birthday question. I'm gonna do this, then we're gonna go on. What's the chances that a dad, a mom,
D.
and a daughter
9.
all have the same birthday?
Yeah, no, what number is this?
I don't know.
26.
It might be, I think it's like one of the bonuses or something.
Yeah,
I
I got
didn't
that
do
one
that
wrong.
one because it was.
I think I got that right.
First, daughter apparently was born last, right?
Yeah.
No,
So
it isn't.
what's the probability that daughter has, or what's the chances that daughter has the same birthday as these first two?
1 out of 365.
What's the probability from that mom has that same birthday? Now, here's where you got to be careful. How many choices were there for the dad's birthday?
Hey, it could be anything, right? 365 all three. Oh, that makes sense then.
Wait, why?
Cause he's like they're doing.
You're starting off, this first birthday could be anything. It could be June 10th. Then the only ones that have to match up are after that. So his could be
Any day.
October 12th, then this one has to be October 12th, October 12th.
So that's one.
So this would be just one, and then multiply those.
I wouldn't have thought of that. We're doing this, so.
Yeah. On the, don't think I forgot. On the other test that we're gonna take here in a little while, we're gonna take it at the end, so we gotta hurry up and get through this. So you wanna have time to review over stuff before it.
I'm just terrible.
It's just the vocab thing, right?
Yep,
From what?
everything.
Everything?
Yeah. Always not be over everything.
I do not.
So what we're gonna start doing, this a little tougher. Thought that stuff was hard, this is gonna be a little more difficult. Probability distributions for random variables and discrete variables. What this is saying is now, you know that, the rain one that we just did? All these problems are gonna be like that.
Oh, wow.
So now it's gonna say, what's the probability that a doctor does a surgery and 7 out of the 12 surgeries that they do are favorable or are come out well? What's the probability that less than 7 come out well? What's the probability that
On our exam.
probably not? I don't know.
Thank you.
It'll be on the final exam.
Okay.
That's fine.
Give me more time.
Are we getting
The
any points
exams
for
would
the, whatever, review?
Yeah.
Can we add that in the
No. If we hurry up and get done though, I might do something to help you out.
Okay, okay.
I really can't.
Depends how much money all of you have.
You can
Uh,
have, you can
I
have
got
my
one
ball.
day my bank.
Right, I was just joking, right.
Let's do it faster.
Because
I know, we were like,
I don't have any money. just
I got
feel
2
like
free
I'm
tacos at Taco Bell.
Hey, I will give you my credit card. Just probably
if I fail this class, I am losing my scholarships for my GPA. And my GPA is dropping hard right now.
Oh, I need this class to graduate.
Can't just be all my classes.
Well, your class is the worst grade, so yeah.
Yeah, your class is my worst grade also. myself.
And I don't know
I
how.
have a 0.
You have a 0?
In French, I can never sing a thing.
Well, I understand it, but I don't understand
I
why
just
I'm
decided
not doing it right.
I'm just not doing it. I don't want to do it. It's ridiculous.
Well, after this test, or before the test,
Is that all online or something?
Yeah, you gotta listen to like one of the assignments was listening to a fluent French person talk for like 30 minutes and then talk about what they said. I did that and I'm like,
What French class are you in?
French degree. I thought about giving Bergen $50 for his laptop over Christmas break so I could have it all.
So a random variable represents a numerical value associated with each outcome of a probability. So it's what it's going to be, and I'm going to show you. We're going to do more with the distributions, like we did for the other distributions where we make the charts and everything. And I'll show you what a set up what the chart looks like for these. But we're gonna make these, and you're gonna have different things. Like I just said something about the doctor. Well, you could have 0 surgeries that go well, 1 surgery that goes well, 2 that goes well, 3 that goes well, 4 that goes well. We're going to list all those in the chart and find the probability of each one of them. All right? And then what we can do to make it a little easier is once you find all those probabilities, if we want the probability that it's 6 or fewer go well, then we just add all those probabilities up. So these are different ways that it could be: a number of sales, a salesperson in one day, number of hours spent on the phone, so on and so on. It's not all that real difficult as far as what you're doing. It's just a lot of it's a lot of work, and you got to be careful and not make silly mistakes. A discrete random variable. You're talking about a discrete random variable. We're going to talk about discrete and continuous. A discrete random variable has a finite countable number of possible outcomes. So if I go back to talk about the doctor, with the doctor, either a surgery goes right or it doesn't go right. All right, so you can count that. There's no in between. There's no, well, it sort of went okay. Now the doctor might try to say that. Well, it sort of went well. He died, but
We got it done.
We got his tumor out, but
Right.
yeah, he's dead.
so that's what discrete means. It's something that you can count. It's not like 1.5, 1 3/4, something like that. It's 1, 2, 3, 4, 5, 6, 7. That's discrete.
So like a car salesman, how many cars he sells?
How many cars he sells.
That's an easy definition.
How many, wrecks there are on Gettysburg Road or something like that.
Was there a wreck yesterday morning?
I think there was one on 70 again.
Because like when I was turning into the school, I could see semis and cars for
I had a 45-minute drive to school yesterday.
Yeah, it literally
I
took
had
me
to
18
turn where I
minutes
live. I
to
gotta
get
turn
there.
up there.
Thankfully, like,
There's
'cause I
some
took
like
my
5
minutes
I was there for 40
Thankfully,
minutes.
a semi like had
I don't-
stopped and like flashed their lights.
I live 5 minutes away.
I would like.
I don't go on 70 anymore. My
But-
wife gets mad at me. I just
Thankfully,
refuse.
semi flashed their
I hate
lights and
driving
like started
in.
from home. I was like,
Yeah.
oh,
Continuous.
10 minutes ago.
Continuous random variable. Instead of being able to count it, there's going to be stuff in the middle. So 0 would work, 0.1 would work, 0.2, 0.3, 0.4, so on. It's stuff that's measured. Might be something like how many ounces are in a bottle of pop, all right? You take a drink, well, there's less in it now. But it's not, every time you take a drink, it doesn't just go down by 1 ounce. It goes down by part of an ounce or whatever. So it's something that's measured. So discrete's what we're going to deal with at first. Discrete's a little easier, continuous, a little more work because there's more to deal with. So were you out there hitting the other day when they were hitting? I was gonna stop up there and
Yeah.
wanted to see who was out there, see
There's actually been a lot of kids going.
if coach would let me pitch, see if any of them are people that I wanna pitch to.
There's probably some.
I'm sure there's a couple. I hopped in the cage a couple years ago when, oh man, what's his name? I can't remember his name now. He was Darren Lee's stepson, Carpenter. He still goes here, doesn't he? Or-
Thomas.
Thomas.
Thomas
He
goes to
doesn't go
South.
there.
He doesn't go here now?
He works
No.
with me though.
Why'd you
He moved
move?
in with his dad.
I'll bet he was trying to play baseball, and so I went down there and I hopped in to pitch.
I don't blame him for wanting to pitch to Thomas. I don't push Thomas too.
And he ran out of the cage like a little wimp. I mean, which was smart on his part. That might have been the smartest thing I ever seen him do, because I have a feeling that a couple of balls were going to get away from me.
On accident, right?
Yeah, I wouldn't do it on purpose. I wouldn't. Decide whether the random variable X is discrete or continuous. The number of stocks in the Dow Jones Industrial Average that have share prices increases on a given day. So the number of stocks, would that be discrete or continuous? Is that something you can count, or is it something that just,
It just happens.
You can count
I
it.
mean, you can count it.
you can count it? So there's like 1, 2, 3, 4, 5. So it should be discrete. The volume of water in a 32-ounce container.
Continuous.
That's continuous. Something you have to measure. It could be 31.5, could be 30.8, could be whatever.
Okay. How does that okay? I'm understanding it.
This part at least.
Yeah, this part at least.
So discrete probability distribution lists each possible value of the random, that the random variable can be together with its probability. I'll put this up here real quick, and I'll tell you what you should write and what maybe not to write. What you're doing on this, a discrete probability distribution is just this. It's a chart. And on that chart, this might be what you want to draw. Discrete probability distribution lists all the possible outcomes, all the X's, right, all the way down through here, whatever they are. And ours are going to have frequency on it too. Maybe if we, just like our frequency distribution had. And then it's going to have the probability of each one. So you're going to have all your X's. This might be 0, 1, 2. And then over here, you're going to have the probability of each one. Probability here might be 0.5. I don't know. Probability here might be 0.3. Probability here might be 0.2. Things that you need to remember. So what I'd write something like this. That's what that's going to look like. The probability distribution, just lists it all out. And then these two things. To be a probability distribution, these two things have to occur. All the probabilities got to be between 0 and 1. All the probabilities have to be between 0 and 1. I think there was a question on that last test that said which of these cannot be a probability, and one of them was a negative. That can't happen. So all of them got to be 0 to 1. And all must add up to one whole. Those two things have to happen every time for this to be a probability distribution.
So we can check our work.
So you can check. My probability distribution that I just drew up here. Are all these probabilities between 0 and 1?
Yeah.
Yeah, so that one works. Do they all add up to one whole?
Yeah.
Yeah. So that would be an actual probability distribution. Now you're going to have some where you make the probability distribution and it might add up to something like 0.99 because you rounded something off.
That's close enough.
All right? If we're making it, that's close enough. Or 1.1 or something like that. If we're making it, that's probably close enough. It's just because we rounded. All right? If they give you something and say, is this a probability distribution that comes out to be 0.99, then you say no. Constructing a discrete probability distribution. We're going to do the same things as we did making the frequency distribution, except we're going to add probability onto it, and I'm going to skip over this. So it's going to look like this. This is what it's going to look like. It's going to look like this chart again and again. We might have something in here that says frequency, and we're going to add other stuff out to here, just like we did on the other stuff. Once we get it done, this down here is going to be the sum. What's that symbol mean again? Summation, total. Add them all up. So this is what a discrete probability distribution looks like. An industrial psychologist administered a personality inventory test for passive-aggressive traits to 150 employees. Individuals were given a score from 1 to 5. A 1 was extremely passive, a 5 was extremely aggressive. A score of 3 indicated neither trait, so it was right in the middle. Construct a probability distribution for the random variable x, then graph the distribution using a histogram. What's a histogram look like again?
The bars touch.
The bars all touch, something like that maybe. So we have this. I'm going to write this over to the side because we're going to do this. This is our x's. We got 1, 2, 3, 4, and 5. And the frequency was 24, 33, 42. What do we need to do with this column?
Add it up.
Somebody help me out and do that while I'm switching to the next slide and stuff.
Push it up.
Oh, it was 150, wasn't it?
Yeah.
They told us that. I hope it adds up to 150 since they told us that.
Yeah, it does.
So if I do this, I write this in here, that's 1, 2, 3, 4, 5. Ignore this extra line that I put on here. This was 24, 33, 42, 30, 21. Oops, missed. Hopefully that adds up to 150. Now to find the probability, all we're going to do, we know the total is 150. How do we find the probability of picking somebody that had a score of 1?
Take 24.
24 divided by 150. Next one's going to be 33. Do these, and then I'll come back and write them in here in a second. This one's going to be 42 divided by 150. We're just changing each one into a decimal.
Are we gonna add extra like things to it like the other thing we did?
Yeah.
This is for discrete, probably.
Yeah. So again, discrete just means our x's over here are stuff like 1, 2, 3, 4, 5. Can't be 1.2, 1.3. Anybody get the first one?
0.16. 0.22.
I'm pointing the wrong spot.
0.14.
What should be true about all these?
One.
See if they do. That's our probability distribution. So what's the probability that we're picking out of these 150 people and we get somebody who was extremely aggressive? So 14%, 0.14. What's the probability that we pick out of this and we get somebody who scored a 3 or less?
Would you just add first three?
So all we do is take these 3 and add them up. What's the probability that we get somebody who wasn't extremely aggressive?
Would that be,
Four and under.
so you add everything but 1
So we could add all these
or
now,
just subtract 1?
or you could just say 1 minus this, and that's where the complement comes in, because it may be real helpful, because this has only got 5 on here. Some of them may have 50. And we probably don't want to add them all if we could have just subtracted off one of them, right? Or probability distribution. A histogram. We draw a histogram for this. All you're going to do on this, we got our scores down here. And over here we have we could make it a percent, or we could just call it the probability. I'm going to call it probability, and we'll use the decimals. So our decimals, what they go from? They went from like
Our smallest was 0.2.
0.2 is not small.
0.14
0.14 is smaller, right?
to 0.28.
So let me go back here. Previous. So it might be better, instead of writing 0.2 here, might be better if I do what on this? Put a 0 on it to make them all look the same. So 0.14 to 0.28. So on this, I might go something like, let's see, 0.10, probably should have went farther. 0.15, 0.20, 0.25, 0.30, something like that, just to spread it out a little bit. 1 was, how much was 1? Anybody remember?
0.16.
0.16. So it's going to come up here, it's going to look something like this. Might be a little high. What was 2?
0.22.
0.22, 0.28, 0.20. So 0.22 is going to go up to about, a little higher than that, about there. 0.20 was the next one, right?
Yeah.
Or was it 0.28? It was 0.28.
0.28
wasn't it?
and 0.2.
That should be up there, sorry. This one was 0.20. Then the last one's 0.14. So that's what our histogram is going to look like. Now, when you make these histograms, notice the way this works, and this is going to be key for later on in this chapter. If I multiply the width of this times the height of it, so if I take like 1 times this, I get the area of that rectangle. That area is going to be important as we go through this, because when we're finding it later on in the chapter and later on in the book, instead of finding these discrete ones, we're going to have something that looks like this, where it's a curve, and we're going to have to find the areas under that curve. So it's important to know that we're finding what we're actually finding here is the area of each of these rectangles. We just did all that. We did all that. That's our histogram sort of look like that. These are just different ones. Are these probability distributions? Again, if this is a probability distribution, what should be true about all these numbers? They should all add up to 1, and they should all be between what? 0 and 1. Are these all between 0 and 1?
Yeah.
So that checks. Then if we add them all up, that's .07, that's 0.20, 0.3, 3, they all add up to 1, so that checks out. This one, all less, or between 0 and 1, if I add them all up, let's see, that's 20, 30, 55, that's 70, 80, plus another 20, that's 100, so they all add up to 1.
Cha-ching.
So each of those are probability distributions. This one you can check, see if it's a probability distribution. That's 0.2. About how much is this one?
Wait,
0.1,
0.4.
0.4. So it adds up to 1.0, so that works, and they're all between 0 and 1.
Well,
I'm not even gonna try to add this one up,
I
but
can't
you
read it.
see how you could do that, right?
Yeah.
The mean. The mean or the theoretical average. Remember, mu is the mean for what?
Mu is
The
population.
Population, right? X bar is for
Sample.
sample. Mean of a discrete probability distribution, we use this formula right here. Mean equals the sum of x times the probability of x. So you take each x and you multiply by that probability of x. Oops, sorry, I didn't mean to do that. Thought there was another. That formula there is the main thing.
So is it the sum multiplied by what?
It's the sum of x
Sum of x multiplied by
times the probability of x. And I'm going to show you on this next slide. That'll make more sense.
Yeah, I'm like, what the?
That's going to give you the mean. So the main thing here is this mean of a probability distribution, of a discrete probability distribution, and this formula right here. All it's going to do, we're going to use all that we had right here. So we had, on ours, we had 1, 2, 3, 4, and 5, right? And all we're going to do is the probability of each one. Does anybody remember any of them? I remember this one was 0.14.
Yeah,
The one above is 0.2.
Oh, yeah, I have
2 and then 0.28.
That was 0.28 up
Yeah.
there.
0.22 and then 0.16.
Wow, look at us go.
Is that right?
Yeah.
All we do to find this next column, just multiply. 1 times that, 0.16. 2 times that is 0.44. About 3 times 0.28,
0.84.
4 times 0.20,
0.88.
5 times that is 0.70, is that right?
Yeah.
Now, all we do, we add all these up.
Can those add up to over?
Yep. And I'm going to show you why here in a second. So these have to add up to 1. These have to add up to the total frequency. What's this add up to?
Just the
2.94.
2 point what?
94.
94. What we're finding is we're finding the mean. Remember, the mean is if we pick somebody at random, we would expect them to be where?
Average.
So that's what mean is, right? It's sort of the average. There's a bunch of different averages, but we'll say it that way.
Okay.
So if we picked a score, this is telling us we would expect that score to be about what?
3. Average.
Somewhere in here. That's all the mean of this probability distribution is telling you. And that's why it can be larger than 1, it can be anything. So
the
we're
difference
saying
when you add them up.
that's what you get. That right here is the mean. That's the mean of this probability distribution when you add all those up. So you have to multiply it by the x times each probability, add them all up, and that gives you the mean of the probability distribution. So we're saying the normal person in this, out of this 150 that they surveyed or did the test on, whatever, falls somewhere in there. So if we picked one at random, we would expect to find or pick somebody who has a score of like 2 or 3. That's what our expected value would be. And with mean, that's what mean is. Mean is the expected value. This is the same thing, just 2.94 shows we did it right. Variance and standard deviation. Write this down a little tougher. Just like with the other one, bad thing is, no way to do this on your calculator this time. We have to do it all out on hand. So you remember when we learned variance and standard deviation and we punched it all into the calculator and did it on the other stuff?
Can't do that.
You're out of luck this time. Gotta use the formulas. Notice the one says shortcut, and I put a question mark. I don't know how that's shorter. I haven't been able to figure it out. If you figure it out, you're sitting at home this weekend and you got nothing to do and you want to just try a bunch of different stuff. Shut up, Lily. You want to just try a bunch of different stuff.
I have a job. I'm saying I don't have nothing to do. I got stuff to do.
Forget that.
I do.
Even if I had nothing to do, I still wouldn't do it.
We know that, Mike. Those two formulas, the first one and then the one at the bottom, those are the formulas we're going to use. Again, what's sigma squared? Make sure you write that on this test we got coming up here in a few minutes. Sigma is the
Sigma is standard deviation of population.
standard deviation of
And that's
population.
the little O thing with 2.
Yep.
Little O.
Sigma squared is what?
Variance.
Variance of the population.
Just the regular O standard deviation.
Does anybody remember what the other ones are while you're writing? What are they for a sample?
S.
S squared is the variance for a sample, and
S is just.
S is the standard deviation for a sample.
Wait, what? What's S squared?
Variance.
Variance of a sample.
Yeah, come on. Yeah, that's right.
I'm trying to get my mind working on 2 things.
Somebody,
Huh?
you give me a file.
Now I'm gonna write this for you.
She's trying to do what she should be trying to do, since everybody's complaining about their grade. Trying to find ways to
This was my lowest grade.
jack
Yeah,
up.
I'm trying to. Anyway.
It was
I'm
at a-
petty, man.
I was at a 73. Now I just don't know what it like. It could be so bad out
Here.
Well, what just makes me so mad is like I think I understand it.
here. Exactly, and then I get to the
And
test.
I
It's just
don't,
like,
I guess. I don't know.
I honestly thought I did better than
But I did good on the little thing we did.
With
The
me,
review,
like-
I understood it.
I don't know. Like, I get it, and then once it comes to test, everything goes blank. I'm like,
So on this is where the rest of that chart comes in. And that's what we're gonna do on the chart. We're gonna do this stuff on that chart. We did the same thing back at the beginning with just the other distributions. But we only did it for like one day and then we went on to using the calculator. So you might not remember real well, but we did this. We made that big long chart with the other stuff.
Wait.
Once you get this answer, what do you do to find the standard deviation? Just take the square root. Remember, if we were using the calculator, it would tell you the standard deviation, and to go backwards, you'd have to square it to find the variance.
So you're good.
Again, I'm not sure how this one is shorter.
It looks longer to look at.
Yeah.
yeah, it
Looks like you gotta press more buttons.
right.
So I'm not sure about
No, we have to.
why that.
Or do it by hand.
So if we're doing this came out to be 2.94, right?
Yes.
so that was that. We take that 2.94 and we take each of our x's and we subtract them. So our x's, this is 1, 2, 3, 4, and 5. I'm not going to fill in this other stuff because we really don't need it. All you do is you take this and subtract this. So 1 minus 2.94 is negative 1.94. 2 minus that is negative 0.94. 3 minus that is 0.06. 4 minus that is 1.06. 5 minus that, 2.06. And most of them will work out in some kind of pattern like that, so once you find one or two of them, the rest of them aren't real difficult to find.
Wait, what did you subtract?
You take the x
X.
Minus.
Okay.
minus the mean that you found down here. And that's that next column. You're going to do that. All these columns are, act like they're filled out because we filled them out on the other ones. Then all you do,
Square it.
you square each one of those. All right?
We got it.
Grab me, yeah, you're going to have to, I can't do this one in my head.
So you just square those numbers?
You just take that number and you square it. Now, before we do this, this is the same idea as on the other one. When you square each one of these, we want, no, we don't want the total this time. Forget, go ahead.
3.76.
And we'll just go out like 2 places behind the decimal this time.
0.88.
This is where you add it. Or no, you square it. Or you square it.
Square it.
0.0036.
1.123. 6. So we'll go 4 there.
Oh.
Close enough. Now we do need this one. So we need this one again. Well, this down here was 0.14,
Yeah, 0.20,
0.20.
0.28, and 0.16.
Now what we're going to do here is we take this column and times it by each one of these. So you take this number, times it by that. Now this time, this is what I started to say on the other one. We're going to multiply this times this.
Psych, you ain't doing nothing.
We're going to multiply this times this times this, so on, all the way down, and then we're going to add them all up. So when you plug it in your calculator, instead of getting each one of these, it might be better to just plug it in all as one thing. This times that plus this times that plus this times that plus this times that plus this times that, and then just get your total.
That's a lot of work.
Well, math is one of them. Right?
I'm not going to comment anymore. All the complaining about the grades and then to say
Wait.
that that's a lot of work is.
Wait, so it's 0.16.
It's not, I'm
This-
not saying I'm not gonna do it.
This
I
number?
have to.
Yeah, okay, I did that. Okay.
Times that number. Those two columns times each other and you add up all your answers.
Yes, sir.
I'm not gonna say I'm not gonna do it, I'm just saying.
Did I say anything? Riley, did I say anything?
Nope.
You did.
I kept my mouth shut. didn't I?
I spend a lot of time on my math.
that.
I cannot wait for lunch, I'm starving.
I'm tired.
Anybody get total?
No, not yet.
Do we know what's in
1.1614.
Yeah, nice.
1.1614?
1.614, sorry.
1.614.
Yeah, I messed it up.
1.614. Anybody else get that?
Hang on.
So you got it.
No, I have to.
Cody did.
Yeah.
Back it up.
Get this from the attorney Dean.
If I go back to this,
Wait, what did the
That's so
total?
fun to do.
hold on, we'll go back to it. If I look right here, that number that we just found by doing all that, that number right there is our variance. That's our variance. That's the sigma squared. So our variance is 1.614. Now to find our standard deviation, what do we do to the variance to find the standard deviation?
Square root.
Take the square root of it. Good. So you take the square root of that. What's that come out to be? Square root of 1.614.
1.27.
Ooh, I did something wrong.
That's our standard deviation. Did something wrong. Punch it in.
Yeah, I don't know. Is that what you got at the bottom, 1.614?
Yeah. And again, all of this stuff, we filled in all this. The frequency, it was filled in on the other one. This was filled in on the other one. That gave us our mean down here.
So,
This is the mean. That's the variance. Then to find the standard deviation, we take the square root.
okay.
Handle that, Lily.
Yeah, maybe repeat.
It's not hard,
Eventually.
it just takes a while to do it.
Now I lied. On your calculator, write this down real quick.
Do you have this?
No, he just said he lied because he said we had to do it.
Don't tell him, he wasn't listening.
You have to do it longhand. So
No,
pay attention.
I don't want
Yeah,
it.
you already have
Don't
it
mind me,
written
go.
down, you don't have to write it.
I don't think any of you need the new calculator part over there, so just this side over here. It's probably explained out more than it needs to be. But write that down. Then we're going to go back and I'll write this up here since it's a little late now, but should have wrote it up here before. This was 0.14, 0.20, 0.28. 0.22, 0.16, I think that's right, isn't it? When you get done, grab your calculator so we can see if it comes out the same as what we just did.
Yeah, the new calculator would be easy, it looks like.
Nah, you still gotta do this stuff, you still gotta put it in there, it's just, it has a different setup. All the changes is like this bottom part right here.
Oh my goodness, it's a lot.
So that'd be the 1, 2, 3, 4, 5.
Scat.
So what you're gonna do on your calculator, you're gonna go to Stat, Edit, and put in the list just like we did before. In list 1, or whatever list you pick, you're gonna put in 1, 2, 3, 4, 5. Then go back to Stat, Edit. Well, no, I'm sorry, you don't have to go back, I don't guess. You can just go over to the next list, can't you?
Yeah.
Go over to list 2, and you put in the probabilities. Don't put in the frequencies, just these 2 columns. So you put this in column 1, or in list 1, this in list 2. Make sure you don't have anything else in those lists that's gonna mess up everything.
And then, vertical.
Once we have all those two in there, go to calculate, go back to stat, go to calculate, go to one variable stats. We've done all that before. Hit enter, and on your screen, did you find it? Stat, then you go over. It'll pop this up on your screen. One variable stats or stat, whatever. Then you hit the second button, L1, it'll pop that up. Then you gotta put a comma in. There's a comma there on your calculator somewhere, you just have to find it.
Oh, gosh.
And then L2, everybody find the comma?
Yep.
Where's it at?
Answer.
It's like right above
Oh, I
the,
got an error.
right above the 7.
I got an error.
If you got an error, that means that they didn't match up.
I'm pretty sure they did.
So either you already had something in one of the lists and didn't realize it, or you missed something.
Let me see your phone.
No, they match up. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
Maybe you're just.
So you go stat, one variant stats,
I got it all in there.
then one after that, so you get this one.
That's what we need.
But I get three.
It popped up. I'm not sure why.
Let me see your list.
Where's it there?
They sent it to me.
Well, I'm saying it's all right here. I don't know what it said before, but that's what you punched in.
Yeah, and then I kept going.
Second, this one, comma. Second, 1, 2. You put them in the list 1 and 2, right?
Yep.
And then there's just
Math.
I'll say there.
No, math. Stats.
Of course it went in.
Which runs here? Second.
Yeah.
oh, that's wrong.
Okay.
And then do it
I had it all
Then you
typed
got
in.
the comma. That's two. Where's the comma? Yeah. That's. But actually, yeah, delete second L1, which is way down there, which is there.
Looking at that, it should have told you X bar. What did it say X bar was?
2.94.
What did we say the mu was?
2.94.
2.94. Those are the same. All right, that's the mean. It doesn't give you the mu on there, but it. So that's the mean. We found that. The other thing that it gives you, look down through there. It should give you sigma x, which is the standard deviation. What's it say the standard deviation is?
Sigma X.
Should be wherever we go.
1.27.
Is that what we got?
We're really close unless we round it.
What did we say the standard deviation was?
1.27.
We're just too loaded.
Now, to find the variance, if they ask you to find the variance, the calculator doesn't tell you that. So what do we got to do to this to find the variance?
Square root.
Square it.
A square?
Take square it. Remember, it's backwards, all right? If we're doing the chart, then you take the square root here to find the standard deviation. This is the variance, that's the standard deviation. If we're doing the calculator, it gives us standard deviation, and we take the square root so that we can find the variance.
Wait, so we square that then?
Yeah.
It's square, right?
Yeah. Here, if you're using the chart, you do the square root.
Yeah. What is, what do you get the same answer? 0.613.
Right.
It doesn't show you that on the calculator.
It doesn't show that on there, so if they ask you for the variance, you gotta do it.
Yeah, no, I'm saying like when I squared it,
But
it
it's
came
not
out to
special
be
like that.
1.6129.
Well, that's because we rounded
But
some off.
symmetric.
That's all I needed to do.
Do you have all that?
I can find it later.
Sure.
You positive, Craig?
I don't know.
So we just did all this, we did it all on the calculator. We found all that. Expected value, just write this, expected value, same as mu. Expected value and mean are the same thing. Expected value and mean are the same thing. not looking like U's, they're looking like M's. Getting,
Don't worry, I can't draw a name.
I just write in
It
you.
says district, yeah. Same as
What do I have? Cheetos.
that's your assignment. Write it down very, very quickly. Speed. Any questions before I pass this out?
huh?
Everybody's just ready?
Sure.
Sure.
I'm ready. Do you want us to do this?
My one question.
My one question is, can
Can we do it next time?
we do it next class?
No,
That's my
no.
one question.
That's a solid no.
I guess not. Then we use our notes. Oh.
Does anybody else notice that I'm ignoring Mike?
Yeah.
Alright. Just wanted to make sure I was getting my point across.
Okay, listen.
I'm ready now.
Alright. I'm gonna give you I wanted to get finished before this. So the symbols test will be next class as soon as you walk through the door.
Okay.
So if you want, as soon as the bell rings, I'll pass it out. If you want questions answered, then be in here a little early and I'll go over stuff for the symbols
Is
test.
it just like the same one as last? Is there new ones or is it
Does
just?
this
Yeah,
have to be
it
done
counts
this
for
class?
This. Extra points added to your test.
If done.
Alright? The assignment's still gotta be finished, that's the assignment. This is extra. If you don't wanna do it, do that to it, I don't care.
See this?
Alright? Extra points added to your test. Do the problems on here, hand it in next time. You can help each other, do whatever you need to do.
Nope. Alright. Everybody gets time. Group FaceTime.
Can I run to the restroom real quick, Mr.
I'm
Ebersole?
not. No, I'm not gonna lie.